for me, you shouldn't be sort of constrained by the software you use to design and to create. I think we are lucky enough to work in the field where creativity is a big part of it. We're building the future, and then we're lucky enough to have an impact in every decision we will take.
Hello, we are back with another mentor interview for Oneistox Expert Talk series, where we have a chat with industry experts from all over the world. I am Dannin, and joining me here today is one of our mentors for computational design, Brice. So Brice is a French-Australian architect and computational designer, passionate with sustainable and climatic-driven architecture. For more than 7 years, he worked at Populous, contributing to several large-scale projects. And now he has founded his own practice and also teaches digital and computational design at Bond University on the Gold Coast. So good afternoon, Brice. Thank you for joining us for a chat today.
Hello, thank you for having me.
How are you?
Yeah, I'm well, thank you.
Yeah, so I think it's best to start off by first talking about your experience so far. Because you have an extensive experience as a computational and architectural designer working in France and Australia and the Asia Pacific regions. So can you please give us a rundown of your professional experience up to this point?
Sure. So I started, obviously started learning architecture in Rouen, in Normandy, next to Paris, where I've done my bachelor and master, and I'm graduate from the architecture school of Rouen, of Normandy. And I learned computational design actually during my master in Erasmus. So I went overseas in Germany, in Stuttgart, at the Staedtliche Akademie der Bildende Kunst in Stuttgart, where I was lucky enough to be in Tobias Walliser's studio for 2 semesters. So Tobias Walliser is the founder of Lava. So I don't know if you heard about Lava, but it's a very innovative sort of company in Germany, and they're based in Berlin, in Stuttgart. I think they've got an office in Stuttgart. They're involved in a lot of sort of Middle East project and large-scale project. So that's where I sort of start learning computational design. The first semester was about biomimetism. So it was back in 2009, and so we had a bit of an introduction on biomimetism, and the way to sort of explore and design around biomimetism was to mold and design using Grasshopper and Rhino. So that was sort of the tool we had to use and had to learn. And then we've done a series of workshops. We also went to Austria for a workshop using Ecotech. Back in the day, it was like this environmental plugin, Gecko, that was working with Grasshopper. So we had a workshop in Austria, and then eventually came back. And I've done the second term was using Maya to compose some architecture and digital design. So that's how I really got introduced to computational design. And then when I came back to France, I got graduate from the architecture school in Normandy, where I had a tutor, Philippe Ram, as a tutor. So Philippe Ram is an architect from France, from Paris, who's working a lot with climate and how architecture sort of could be driven by climate, and form and shape are driven by climate instead of the sort of the traditional way of designing architecture. So I was really passionate about his work, and I worked with him for 6 months in Paris, where I've done a bit of computational design, used a bit of Grasshopper, but it was already pretty late in the process. It was on the EcoJet park in Taichung, in Taiwan. So we worked on this project and I worked for 6 months there. And then after, I went back to Normandy and had another experience in an architecture and more traditional architectural firm. And I missed sort of Grasshopper and Rhino, so the competition side of it. And so I decided to have a break, and then I came to Australia to travel. And after a couple of weeks, I got an interview at Populous, and I started working at Populous as a computational designer to help the design team on a project in Saudi Arabia for a bit, and then on a couple of projects in for Populous. So in 2009, I became associate at Populous, and I found the computational design group in the APAC region. So and then we're like sort of having those regional meetings and the global meetings with the London and the US offices to discuss about like sort of computational design, where we go and what we could do and what comes next into the world of computational design. In terms of project, I've been lucky enough to work on quite interesting project at Populous. I was working mostly on stadiums, facades and roof. So some of the project were like the KL Sports City in Bukit Jalil in Kuala Lumpur. Another sort of large one was for the National Speed Skating Oval for the Beijing Olympic, the 2022, where I was working on the facade and the roof. And finally, and then I work on like a couple of like sort of airports, a lot of like sort of competition and design competitions. And then the last one that is built is the Kai Tak. It's in Kai Tak in Hong Kong. So it's the main stadium from the Kai Tak Sports Park in Hong Kong, which is on the river, where I worked mostly on the facades and roof. So same idea with retractable roof and a 50,000 seat stadium. So very interesting project. Well, I spent like the last 4 years on it, 3 years from competition all the way to completion. And then I left Populous after I finished this project. And then I start teaching at university, and I start my office as a consultant, where I help sort of architect and designer through computational design and BIM sort of work.
Thank you. What a journey. So you started with you started this journey with computational design in your master's, and so and you have been working continuously with this computational design technology since then. So what does BIM and computational design mean to you? How have these digital technologies helped you in design?
It's a very good question. For me, when I first started, I found that for me it's more like a help for design. So for me, you shouldn't be sort of constrained by the software you use to design and to create. I think we are lucky enough to work in the field where creativity is a big part of it. We're building the future, and then we're lucky enough to have an impact in every decision we will take. And then I just found like that, the shortest way from ideas to paper is obviously through your hands and hand drawings. And so I do a lot of hand drawings to sort of translate those ideas into paper. And then come the fact that the stage where you need to put that into the 3D world. And I think that's where sort of computational design tool could be, and software such as Rhino are like a bit more free in terms of modeling. And I think it's very important for me to have like this flexibility on, okay, I want to design that. Which software should I use for that? And what would be the most efficient way to model that?
So it's all about the efficiency, about translating the hand drawing to a proper 3D model and design. So we did mention about we mentioned the term computational designer quite a few times already since we started. But for some, this term itself, computational designer, can be something that's very broad or even unfamiliar. So can you tell us the type of typical roles in the industry?
Yeah, sure. So it's a bit of a tricky one because it's like, so like, when you're an architect, obviously, like there are sometimes needs that, like you don't do only computational design. I think for me, it's more like um, being very good in Excel as well. And then you do a bit of Excel time to time, but you also need to do reports, and, also need to do some more like sort of architectural roles, because obviously like the part where you design and build the script is some part of the job. So I guess for me, it's like computational design is sort of having an extra sort of skills in your skill set, and being able to jump and help on specific aspect. It also, I guess, allows you to do a bit of more design. Like when I was at Populous, I work a lot with Gavin Robotham from a Grab Studio, and then like working with people like Gavin is absolutely amazing, because he came up with all the sketches, and then you have to figure out and model it in the software in Rhino, or like even in Grasshopper. So sometimes this sort of, Rhino is not a computational design tool, so sometimes computational design is only when you bring it into Grasshopper. And it's as you say, it's a very broad sort of term, because some would argue that Revit is also like a computational design tool. So it's, as long as you've got sort of parameters and element to play with, then that's sort of start to become like a computational design tool, I guess. What's interesting with Grasshopper though is that you're building your own logic. So I think it gives you like a very good advantages. Like when people use Revit, for example, in the industry, you sort of constrained to a certain type of architecture. Having Grasshopper and parametric skills would like sort of drive into like other aspect of the design, where you can explore other paths, other design paths.
Then we talked about what computational design can do, but what does a typical day at work look like for a computational designer in the field of architecture?
The difficulty of it, or like what was it, the challenges?
Like what does if you are a computational designer, so what does your typical day at work look like? What is it that
Okay.
what are like the
Yeah.
responsibilities?
Okay, so well, what's interesting is like some people will come to you and say like, I would like to do this, or this facade. I would like to work on this type of design. So some will come with sketches, some will come with we will get involved, you do like a design session, and then we talk about design and see where we want to go. And when we're all happy on like the direction of where the design should go, that's where we sort of question and have a think about what would be the best tool to use. So like I'm a computational designer, but I also like I'm also like using Revit and other software, because for me it's more about finding the best way to go where you have to go in the most efficient time and way. And so basically that's how it works. So you work like with the design team and try to find the challenges and what we could do, and also how much options and where do we want to sort of orientate the design exploration and the iterative process. So you basically after that go on your own and figure it out. So that's what we call the computational thinking. So it's where you basically combine all the items and all the elements you need to take into consideration in the design, and also evaluate where the design could go. And that will help you to define your variables. So what sort of changes will happen, of what are we going to explore, which option are we going to explore, and then you build sort of the script and the code according to this those criteria. So if you think that some of the like the thickness of the facade will change, that's something very classic, or like the set out of the grids will change, you set up your script the way that you could easily change that with a slider, or change that with a very easy way to set up and to change, so to explore the different ways. So you sort of know where you're heading, and then you got all those branch of opportunities that come up. And obviously sometimes in design, you go in one way and you think like it's going to be this way, and then suddenly like you actually think like up with the team and you think like actually we're going this way, so you just have to change the strategy, sometimes rebuild the script to explore more. So that's a bit of the day. So you figure out how that works. So you sketch a lot. So I sketch a lot, and then you break it down on what's the structure and how you're gonna write the story. I really like to say to my students, it's like, for me, it's like we say like scripts, because for me it's like it's really a story you're gonna tell to the computer. It's like, where do you start, where you go, what are the parameters, what are the changes, and it's just like you build this story. So you can do a storyboard. It's a very creative process, despite the fact that it sounds like, or it looks like very engineering, but at the end it's very creative, because you have to build and find your own way of telling the story of where you want to go.
So some of these items that you mentioned are commonly presumed to be the responsibility of an architect. I'm sure like there are certain similarities and even like differences in your role and that of an architect. So is the role of a computational designer very different from that of an architect? And like, can one still utilize computational design in their workflows without actually having the computational designer title?
Yeah, sure. Like, I mean, like, you can do, as I say, it's really a tool you can use. And then, how often you're going to use it is really up to you. It's good to know it, and good to be able to use it. And then when you end up like working in like larger companies, it also depends on the scale. You might need to have people that are more specialized, that will do a bit more. But when you work on like small scale project, you will likely use computational design at certain stage of the process, but maybe not all during the whole process, but maybe in certain chunk of the process. And then on large scale, it's sort of like a change, and some people will likely use it a bit more. But I guess it's, as I said, it's just sort of give you this freedom of composing, and also like the efficiency behind. So what's something very interesting, and especially with like Rhino Inside, it's like there is more and more sort of efficiency aspect, also like dragging not only in the design phases, but now like also in the documentation phases. So you get like amazing shortcuts on how to produce drawing way more efficiently. So set up some workflow and automation to really improve your everyday life, and avoid having repetitive tasks, and being like super efficient, because nobody really likes repetitive tasks. So it's really interesting to push this aspect, because it just improves the quality of our profession overall. It's just being able to, it's like knowing Photoshop very well, so you don't have to you find better way to be more efficient. So it's really about efficiency, and try to focus on what we like to do, and sort of automate what we don't really like to do.
Okay, thanks for that. So this next question I have for you is something that I personally am curious about. We know that your computational design is getting really popular. It's an in-demand scale. But what is the scope of it, the scope of computational design for the AEC industry at this current stage and in the future?
Okay, so I think it's interesting, because I start learning it in 2009, so really at the start, at the beginning of it.
Yeah.
And it was really early, sort of, you know, like even in France, nobody really was interested about it. So it was really in Germany where sort of like they were like the most sort of traction into it. And when I went back to France, everyone looked at me and was like, "What is that?" So like, so there is like it took a while to take off and to sort of understand and see the interest. And I think the industry is the same today. Like you know, with my company, like sometimes I sort of try to convince or like try to talk through like what's the efficiency or like how we can, you know, improve the process. And I think the industry is still like sort of trying to catch up on that. So like, you know, BIM is sort of the new things. And I think computational design is still like very new, even so like, you know, I've been doing it for more than 12 years, but it's still like pretty new in industry. So I think today it's still like more like video like you do, or like, you know, like sort of communicate of like what can we do with this, and sort of try to explain it and break it down to explain how that could be efficient, how we can be more creative, spending less time on repetitive tasks and being able to really push the industry forwards in terms of quality and also like time efficiency. And I guess from that, the future will be the same sort of things. I think the people will adapt. For me, we are like a bit at the same time, at the same sort of transition as like, you know, from AutoCAD to BIM, or like, you know, 2D to BIM or 3D, where we like where some people like sort of want to stay in 2D, and we see less and less people doing that because in terms of efficiency, you can't really do. So you've got a company that will work in 3D and then a company that will work in 2D. And it will be very hard for the company that is working on 2D to keep up with the speed of like the person in 3D. And I think same as when, you know, like went from hand drawing to CAD, sort of this transition, and it's happening now also in computational design and sort of the BIM world, where you've got like some people who like start to have it in 3D, but then they also have 2D, and then, you know, work on in Revit, but they are constrained by a certain like sort of architecture or like way of doing. And then you have those people or those industry that will adopt computational design in their sort of workflow and in their system. And I think that's where it goes, because there's so much potential. It's open source and it's expandable. You know, like it's really interesting because, and then you've got really a lot of talented people that put the effort on like creating some amazing plugins that are used like every day. And I think that's really, really nice, and it's really good to have those people like contributed to this community, and this community of like, you know, Grasshopper has been a community still for the last 12 years and has been an amazing community, helping each other, and then sort of, you know, like you can find anything you want on this forum, and so it's really interesting community. I think it's exciting. So I think in the future, as long as this community will stay and then will be like still like sort of, okay, I got help, I will help sort of mindset, then I think we will keep sort of, it will keep happening in the future, and it will keep like sort of thrill.
So yeah, so that means like, you know, there's so much potential of how architects can actually use computational design, or, you know, the scope of computational design for the industry is just so broad that it's very hard to actually say exactly what we will have next. So in your opinion, why should architects learn computational design? What are the career benefits to be gained from learning these skills?
For me, first of all, it's fun. It's really cool. It's really fun to learn, and I think it's very creative. So like, you know, it doesn't look like it, but it's fun and creative. It's there's a lot of problem solving, and I think it's a skill. You know, I was talking to my partner about that, and I think like, you know, it's a skill like as a student you need to have to get you through the future, because problem solving no matter what's going to happen with AI and all the, you know, the evolution of the computational science, and then problem solving will still be something that, you know, like we love to do, and it's good to be part of it. So you learn that, and that's amazing. And also, like, I think it's just it gives you really the opportunity to be creative. So I think you are creative, you set up some problem solvings, yeah, I think that's what's really exciting about it, and then it just like gives you really like some really good skills for the future, get you ready for the future, for what's come next.
So we earlier we talked about the potential of computational design for architecture, and we're also, you know, witnessing many architects taking it up. But I'm also curious, can computational design also assist engineers?
Yeah, sure. And I think like we saw it, like, to come back to the architect, we saw like Rhino Inside, for example, coming more and more comments. And I think Rhino Inside is like it's amazing aspect of Grasshopper that some very talented people like sort of work on it and work hard on getting that developed. And that will like, that's a game changer, because you suddenly have like sort of the power of Revit into Grasshopper, but also the power of Grasshopper into Revit, which is gonna open a lot of opportunities and doors. And I think like this is a game changer for architects and the industry. And about engineering, I guess for engineers, there is also a lot of studies that can be also done to a certain level for architects, like in terms of performances, sustainability, also like embedded energy, and sort of life cycle assessment. So all those sort of strategy that are in the field of engineering, also like structure analysis and all those type of like sort of aspect of engineering are also into computational design. So a lot of engineering firm already use computational design in their workflow, in their process. And I think the architects are a bit behind in terms of like using it in their process. But I think it's also the opportunity for the architect to embrace those software and those you know, climatic simulation. I'm thinking about Ladybug and Honeybee, that are absolutely stunning sort of plugins that you can use in Grasshopper and Rhino. That's what we teach as well at Bone, to like have a better understanding of like the climate and how your design is impacting the climate, and how your design is responding to the climate. And I think that's a challenge for the future, and we really need to embrace those sort of engineering aspect of architecture. So I think engineers are already using it like very well, but I think architects really need to embrace it, so we can have better, more informed designs through data, and more informed decision making through data and computational design. So I think that's where, you know, the exploration and the room for improvement can be.
Okay. So yeah, thank you for that. So you talked about teaching at Bonn University. Yeah, so you have been an educator with over 2 years of teaching experience in digital design at university level. What actually got you into teaching actually in this niche?
I think I just want to share some of the some of like my knowledge, but also like sort of, you know, give the opportunity to students to also have the chance to learn computational design, because for me it just helped them and prepare them for the future. It's not only that, and I think it's you know, it's a tool, it's a part of the learning. I believe there's a lot of things that need to learn, like you need to learn to be an architect. So computational design is just a small part of it, but I think it's an important part because it's it sort of introduces you to coding, and I think if you like it, it's sort of Grasshopper is an easy way to get into coding, and if you like it and if you're interested into it, you can obviously develop your skills in Grasshopper and understand the logic and the structure, and then eventually sort of get into Python or Dynamo or like other type of coding. And like I was using like Blender the other day, and and then like this graphic sort of Grasshopper style part of the code, and I found it very familiar, and I was like, oh yeah, that works like this and like this. And I think it's just give everyone sort of the chance to understand a bit of this word and be able to learn it further if you're interested. And it also, like, I really believe that we're gonna have to embrace this technology to be able to tackle the challenges we have with net zero, and the better sustainable sort of architecture, because using this informed decision to make architecture is something we really need to tackle. And I think having those tools available and make it available, it's open source, so it's amazing. You can just download, so it's accessible for companies, so they don't have to invest a lot of money in software. They just need the people to be able to do the study and give information, and prototype the project and have all the information early enough in the process. And I think that's what I'm really like thrilled to sort of teach that, because I think it's important for students to, and for future professionals to be aware about that, and being aware that it exists, and we can we don't need we can sort of have an idea of climate and climatic parameters just very early on in the process, so we avoid making mistakes that can't be resolved down the track. So it's really, really interesting to teach that aspect to the students. And like I'm teaching fabrication as well, because I think there is some really interesting aspect of fabrication and computational design. So we're doing like waffle structure at the moment with the students. So like, how do you laser cut, how do you 3D print items, how does that comes together, what type of geometry, and also how to be efficient in your iteration process. So using Grasshopper is very interesting for the same idea, testing idea, being efficient in your workflow process, not redo the same thing, but think about how you're going to do it. You're going to do it one way, and then you're going to have a multiple outcome out of this specific way.
Thank you. That was very insightful. And I think it's also very interesting to actually have, those who are already practicing in the field teaching, because that gives an actual like industry relevant knowledge to the learners. Thank you for that. Okay, right. So now we are actually down to our final question, which I think is actually a very appropriate question to add on, since you're an educator. What advice would you give to fresh graduates and young architects out there who are interested in learning computational design?
Wow, that's a big one. I always found, like, I think one thing that, overall, not only for computational design, but I think for fresh graduates or for people that really want to learn about architecture is just being curious. Being curious and just like always wanted to learn and find ways to learn. I think we live in a beautiful world where we can learn a lot from YouTube, from internet, from reading a lot of things. So I guess the only really good advice is being curious, try, test, spend some time. If you like it, find something you like, because it's always easier to get some energy and then get the motivation when you like what you do. So find what you like, and then just go and go deep into it, and enjoy learning about that. Always trying to find a way to learn it with like in a fun way, because I think it's always, it's the only way you really learn. It's by having fun and enjoying. So yeah, I would say be curious.
Yeah, I think that also is it makes sense. So, if you're not curious, you don't really want to learn anything. Curiosity is what actually drives someone to, go forward. Yeah, I think so. That's a very good advice to, especially to, students who are really interested. They will definitely find all your information helpful. But thank you for joining us today, Brice. It has been wonderful talking to you. You have shared many great information that I'm sure like all our learners will find very useful.